Awesome. We are live and the audience is streaming in. Okay, we are already 100 plus. I'm just going to wait for a few seconds for everyone to come in before starting. In the meanwhile, those of you who are already into the session, welcome. Thank you for joining in on time. If you can quickly mention in the chat box if you can hear me clearly, if my audio and video are clear and you're able to understand what I'm saying, just say a quick yes in the chat box, please. Okay, I did get some confirmations. And now, since you're in before most of the other people have come in, why don't you also mention the cities that you're dialing in from? So wherever you are currently in India, just mention that city in the chat box, gives us a feel of where the audience is coming in from today. Okay, Bhadurgarh. Okay, Mumbai, Chennai, Patna, Jaipur. Okay, Indore. Well, lots of people from Mumbai, Nagpur, Chennai again. All right. Kerala. All right, Thrissur. Vaishnavis from there, and then more Nagpur. Lots of Mumbai folks in the session today. Okay. And I see someone from Goa. Nice. Okay. All right. So actually all over the place, the audience is coming in from all over the country. That's great to see. And we are around 350 people in the audience right now. So let me kickstart and do the quick introductions now. Good evening, everyone who's in India. My name is Sanjay Dhingra. I'm a co-founder and director at Seed Global Education. So this session is being hosted by Seed Global Education. Today, joining me in the session, and very kindly, I have Dr. Kinga Dobolyi. I did get the pronunciation wrong. I'm going to work on that and get it right soon. So I have Dr. Kinga joining us, and I have Brittany Wright from George Washington University School of Engineering and Applied Sciences. So GWSES is how it's called. Now, today's session is extremely exciting, and the topic which is the emerging trend in the world of technology. So very interesting over there. So machine learning, software testing is what we're going to speak about today. A little more about before I get her to start the session and talk to you about the whole topic on hand today. I'm going to launch a quick poll to gauge what year of education currently you are in or what background you're coming from. So you'll be able to see the poll on your screen right now, which is about if you are looking to study. Okay, now the poll is live on your screen. So if you are able to see this poll is about which year do you intend to start your master's studies. So I know a lot of you are currently in college, so you must be in pre-final or final year of your undergrad education or engineering. So just to get a feel of which year you're targeting to start your master's studies abroad or master's studies overall. So this poll is about that. So if you can select the year, that's going to be great. Okay, I do have around 150 responses right now. I'm going to keep this open for another 10 seconds to give you a chance to respond. So if you haven't yet responded, do so now. All right, so around close to 185 responses. I'm going to keep it another 5 seconds and hope if we touch 200 responses. So if you haven't yet responded, do that. Again, the responses have started coming in. Okay, at 196, 198, and just about 200. Awesome. So yeah, we do have a spread out audience. We do have around 35% of the audience who's looking at next year or 2023, and the remaining 60-odd% looking at 2024 or later. So fairly young audience as well in the crowd. So these are the early starters. Very interesting. Let me come back to Dr. Kinga now. So Dr. Kinga is the Associate Professor of Practice in the Department of Computer Science at the George Washington University. She's not just a theoretical academician, she's also a practitioner. So she's worked in the industry as a data scientist for many years. She was with a not-for-profit called IQT Labs, where they specialize in biomedical applications of computer vision and NLP. So really cutting edge of technology over there. Dr. Dobolyi earned her Ph.D. in 2010 from University of Virginia and has been in academia and industry ever since then. So over to you, Kinga. Handing over to you over here and looking forward to your presentation.
Thank you so much, Sanjay. And good evening, I should say, everyone. Let me just take a minute here to share my screen. And are you guys able to see those slides? Okay, and sorry, this is now, this is just me getting used to. Okay, full screen on the slides. Great, I'm just going to minimize the window here. And Sanjay, I go till 10:10, is that right? On our time?
That's correct.
Okay, perfect. So thank you so much, everyone, for being here. I'm very excited to give you guys this talk on software testing in the age of machine learning. And I'm just copying over sort of the blurb here, what we're going to go through. And I think that this is such an exciting and important area of machine learning and of computer science, because these machine learning models and products are becoming ubiquitous. We're starting to see them in all kinds of systems. You've probably interacted with them many times, maybe with knowing, maybe without knowing. And so these systems, like all systems designed by humans, fail, but they're very difficult to understand, not only in how they fail, but also how they can fail, et cetera. So testing machine learning models is becoming increasingly important, especially in industrial settings. And to be honest, currently there are limited ways that we have to gain confidence how these models might perform when deployed in the real world. They can be, these systems are often deployed in sensitive environments. And so if they don't work, if they have failures, if they're biased, that can really have a very negative impact on individuals. So what I want to do today is just give you a broad overview of what it means to test these machine learning models. I'll have a couple of specific examples from industry companies that are working on this, and then I'll lead the talk with topics that academics are looking at, as well as sort of the future view into where this subfield of machine learning and software testing might go. What are machine learning failures? I picked just a couple common ones, but there are so many ones that might be more famous, or other ones that you might not even know are happening. Here are some examples. You might have seen or read about or even experienced facial recognition software. So just sort of a camera image is able to identify a face and tag it as a person. In China, and they had software, allegedly, I'm just sort of reporting things in the news, that would try to tag jaywalkers. And so there was a bus that drove by in front of the camera. The bus had an ad with someone's face on it, and that person got tagged as a jaywalker, and I presume they got a ticket. And so it's just sort of these awkward situations. Maybe one that's a bit more disturbing. Amazon, I believe, used to use the artificial intelligence powered recruiting tool to help find candidates for openings. And it turns out that tool wasn't rating candidates in a gender neutral way, which is really, really bad. And so they're not using it anymore. But these sorts of systems can have really severe consequences. And to take it perhaps one step further, I believe that there are mobile apps to detect melanoma. So that's a type of skin cancer. Based on, you take a photo of your skin, and you can imagine how bad it would be if that app sees cancer and tells you you don't have cancer. These are some of the more famous or accessible machine learning failures, but there are probably lots of other failures going on that we don't even realize are happening until maybe it's too late. So this is a really important area to research and to focus on, and to have best practices as practitioners, because these types of models, these AI models, are just going to be more and more ubiquitous and used everywhere. The problem with testing them is we don't have a great way yet, with automation and all of these good tool support that we'd like, to test machine learning models. In terms of traditional software, if you are more familiar with that, when we test traditional software, we know the inputs, and for some inputs, we know exactly what the expected output is. And so we can write unit tests that evaluate this logic, where some sort of human designed set of rules, or maybe it's nature, but something that we know is able to turn those inputs into expected outputs. And so for every input, we know what is the result that we need to get. And for doing testing, you may not need to test every single input. In fact, you can't, but you can often characterize the valid ranges of these inputs in a meaningful way. For example, imagine that you're writing a website that will calculate your GPA in school based on your transcript. So it has to know your grades, it does some math there, and then it shows the overall GPA to the student or the teacher. You can imagine how to write unit tests for this. It's very easy to add together a bunch of grades and then take their average or whatever you want to do, and this can be verified. Testing machine learning models is a little bit different. We're not really talking about testing the logic of the code used to build the algorithm. So there is code that's responsible for learning what you have from the training data. And you can, of course, write unit tests for that, just like traditional software. But what we're actually talking about, or at least what I'm going to talk about today in this talk for testing machine learning models, is we're focusing on testing the data the model is trained on. And that's sort of a weird concept if you haven't heard of it before, haven't thought of it that way, rather than testing the actual code, which can also be done, but that's sort of traditional software engineering. I'm interested in testing the quality of the model that we're building from the training data. So here's an example. This is a well-known data set, or images from a well-known data set of skin photographs of skin. There are two cancer images. I believe they're the dark ones, the melanoma and basal cell carcinoma. The other ones, I think, are all benign conditions. And so if you are trying to build a model that can detect the melanoma, let's say, or the basal cell carcinoma versus the other ones, you need a lot of images. You need high quality images. You have to have representative samples. I don't know how much all of you might know about melanoma or not, but on your skin, these sort of suspicious moles can look different, small, large, et cetera, et cetera. And so that's much harder to gain confidence about, that you have an adequate training data set that isn't biased, et cetera, to build a good model, as opposed to testing the logic in the code. So questions around how to build this data set arise. How many photos do you need of melanoma, of the other conditions, skin conditions? That depends on how similar these look to one another. Are there potential biases? For example, if you visit a dermatologist and you have a suspicious mole, they'll usually biopsy them, and they might take a little blue marker and draw a circle around that mole. And so it could be that in your data set, it's quite common that all the melanoma has a blue circle in those images just because the doctor circled it. Maybe your model learns to detect blue circle rather than detect melanoma and just gets those two confused. And then one day, if you showed an image without a blue circle, it'll just say it's not melanoma when it obviously was. Those kinds of issues. Maybe your data set has a limited number of skin tones, and so it won't work on people with different skin tones than what the model was trained on, which is really bad. Perhaps the magnification of certain types of lesions might be different. So for example, maybe the melanomas tend to be larger, several centimeters, versus the dermatofibroma, maybe 1 centimeter. And so the model doesn't learn to see the differences in terms of those growths. It just kind of pays attention to what the magnification was. And that's not what you want, because if you change the magnification or have a different size lesion, you're going to run into problems. And there are lots of other examples like this. From a testing perspective, what I might do, what people tend to do with this particular type of application, which is looking for cancer, you could measure raw accuracy of how often it says, yes, this is cancer, or no, this is not correctly. But I believe that melanoma is relatively rare compared to benign moles and other healthy skin. If you built a model that just always said not cancer, it would have really good performance overall, but it would be a horrible model to use because you're telling people the wrong thing. And so we think about things like precision and recall and other metrics here. And that's sort of a lot of the testing that people do nowadays for the models that they do build. They evaluate how well it performs. However, that's on some limited test set and the training set that they used. And so how the model generalizes beyond that is difficult to tell. And that's what we're going to continue talking about today. Another example, moving away from sort of biology, is how to predict clothing items. So this image on the right, I believe, is from Stitch Fix, which is a company that has people take quizzes, and you sort of rate, oh, I like this outfit or I don't. And then they will say, I think you will like this outfit in the future. And they mail it to you and you sort of wear it. And so one of the issues here with this algorithm, if you have a person who's never answered this quiz before, and it's more questions than just this one, but they're more like this, you've never seen these set of answers in your training data set, how do you know that what outfit your model predicted is the one that's correct, or is the one that they would actually like, unless you ask the person? So there's a lot of these kinds of scenarios in machine learning that we don't actually know if the prediction was correct or not until someone eventually receives a product and returns it, or things like that. That's one of the issues with something like this. Another one might be, for example, maybe 3 years ago when I trained this model, orange was a very popular color. Everyone loved orange. Every time you showed them an orange shirt, they said, yes, I would wear that. You build a model, it has great performance, it loves to recommend orange. And then 3 years later, no one wears orange anymore. Maybe now they like to wear purple. And so a model that worked really well when it was trained has now reduced its performance. There's been this shift away from orange into purple. And unless you're aware of that, you may just not know that the model doesn't work as well as you thought it does. So I'm saying all this just to illustrate that machine learning testing is hard. You can certainly unit test the libraries that actually train the weights of the model, et cetera, and build whatever kind of model it is. But how do we, these traditional software engineering testing techniques aren't really set up to test the data, which is what I've been talking about on the past couple slides. A way to formalize this that you might have heard before is that machine learning testing suffers from what we call the Oracle problem. There isn't an easy way to tell if your results are correct or not. So like we said earlier, if the model has never seen these sets of inputs on this outfit quiz, whatever it spits out, we can't check if that was right or not until we ask the person, the customer, did you like this outfit or not? So that's sort of something difficult. And if we knew the right answer, we'd have a set of rules to predict, or rather find perfect outfits for people, and you wouldn't need machine learning. So this Oracle problem is intrinsic to the world that we're going to talk about today. Another example, how many pixels can I change in an image of a cat before it's no longer a cat? I'm not even sure humans agree on that. And so all of these details make it very difficult to test the correctness of these machine learning systems. The algorithms aren't necessarily stable. So we talked about that shifting from orange to purple as a favorite color, something to consider. The real world correctness of your model depends on the training data. And I just said bias, bias, bias here, which is related to software testing for these models. I won't talk about bias today, but that's another huge problem that we have that people are trying to address. So currently what people usually do, and what I've done in industry for the most part, is try to do our best that we can to validate the model that we build on the data that we have at the time, using cross-validation, and that sort of thing, but that doesn't necessarily capture all the possible failure modes that we talked about. And so I want to just give some additional tools in industry that you can use, and then talk about a little bit of research in academia to take it further than what people have commonly done so far for evaluating their machine learning models. Just briefly, I want to mention or sort of define what are the failure modes in machine learning. And I lifted this table from this recent paper, I think it was 2020, Failure Modes in Machine Learning by Kumar and others from Microsoft. There's a lot of research on intentionally motivated failures from machine learning, poisoning attacks, perturbation attacks, all this sort of stuff, membership inference. These are not the things I'm going to talk about today. What I actually am going to focus on are, from the same paper, what they're calling unintended failures, and specifically mostly on bullet number 6, which is just incomplete testing. So the system was not tested under the realistic conditions it's meant to operate in, or maybe it was 3 years ago and those conditions have changed and there's some distributional shifts, etc. This area of research, especially the incomplete testing, is much less populated right now than some of the other ones that we've mentioned. So it's not a mature field yet, which makes it very exciting, I think, for me at least, to work in there. And I'm sure there'll be a lot of other great tools that people invent as we move forward. I'll show you a couple of them from industry. But what I wanted to just sort of actually, well, I've had a slide on here, but you can't really see it. You can look at the link later, but there aren't actually a lot of companies that are serving tools for automated testing of these machine learning models, because it's difficult to do. The research landscape is also still growing. So what are some example tools from industry? Some companies that have come out with this or are working on these problems. One of them involves model assertions. We said earlier that we don't always know what the expected, or rather the exact correct output prediction should be for a model. So if I have a model like Zillow in the US, or some other model that is predicting the price of a home based on how many bedrooms and where that home is and what it's made of, things like that, maybe this model says some home is $100,000. Well, is that the right answer, or was it $105,000? So we might not know the actual correct answer, but we can often specify assertions about the range of valid outputs. A home price should never be negative. We know that we have done wrong if the home is negative. If you have a home with 5 bedrooms, maybe you know it's always going to be between $100,000 and $200,000. Maybe you know that the home price prediction should never be more than 20% different than what you predicted last month. And so these are rules that we can come up with as a human using our subject matter expertise. And then there's a tool like from a company association called Great Expectations, where you're able to code up these assertions. So you can see here, there's a column for room temperature as an example, and then we're specifying that that temperature needs to be between 60 and 75 degrees at least 95% of the time. And you can imagine how to apply this to the home examples that we just went through. Another tool that's out there relates to data set slicing. And what this means is you can select a subset of the data that meets certain criteria. This is really useful if you have your training data and you're interested in looking at, does it cover these sort of edge cases? For example, if you're processing sentences from customer reviews or something like that, does your model handle sentences that are very short, 5 words or less, effectively or not? Or does it handle very long sentences? Or maybe there's sentences that relate to, you know, the happy reviews or the upset reviews, etc. So you can specify a slicing function like we're showing here. And then with this tool, Snorkel AI, you can actually use that to slice your training data into these pieces where you can focus on just one particular type of data and check for this minimum functionality. Does your model serve it well or not? Another thing that's quite common out there is data set profiling. So this is a way to measure your model performance over time. We talked about how that's important with the outfits that shift from orange being our favorite color to purple. So we can, with these types of tools, detect these style differences in the train and deployment data distributions. Is there drift? You can also use these tools to detect bias in the model predictions. There's some links here from Fiddler AI, which is a company that provides a tool that you can use to do some of this. I'll actually show you the second one here for bias detection. Sorry. Whoops. Let me just expand this. So for example, and I know the video that they have is very fast, they have a prediction or a model that predicts something, and they've defined race and sex as these protected attributes that they're interested in. They're looking at a particular outcome of the model, and then they're checking, does it, I'm assuming, because it's very fast, I couldn't see, but is the model predicting those outcomes favorably for all the different combinations of these protected attributes? So these are some examples that we just went through of testing tools from industry that people use in industry who are developing these machine learning models to gain some confidence that their model has minimum functionality, isn't biased, that the performance doesn't degrade over time. These are very useful tools, but they're still missing some desirable features, which is no one's fault. It's just that machine learning is relatively new, or at least modern machine learning is relatively new. It's really taken off, let's say, maybe in about the past 5 years. Some things that would be nice to have are automated generation of test cases rather than you having to manually specify certain things, and handling of more complex data types such as imagery, audio, etc. So there's a lot of room for improvement in this field. I find this very exciting as someone that is interested in this type of research. And so let me share just a couple things in terms of what academia has done so far and what they're focusing on to try to address this problem. So just as a reminder, one of the issues we have with machine learning models is we face this oracle problem, which means when you have a set of inputs that your model has never seen, and it predicts something, you don't actually know if that something is correct or not. You just don't have a way of knowing until that event happens in the future, etc. So what are some proposed solutions to the oracle problem? One of them is to use pseudo-oracles. And what this means is you will train multiple different machine learning models on the same data set and then compare their results. And so this works really well if you, for example, have a data set and you build what's called a random forest, which is one type of machine learning model. Compare that to maybe a linear logistic regression, which is an even simpler type of model, and compare that to some sort of deep learning model and try to see, are they all performing loosely the same? Maybe one's better than the other, but do they agree on what the correct answer should be? So this is useful. It's expensive because you have to train all these different models. And if the problem is in the training data set or how you're evaluating it, this approach will probably not reveal that, which is a limitation. So another thing that researchers have proposed to help solve this Oracle problem, again, because we don't know what the right answers should be, we don't know how to grade them, is called metamorphic testing. And here we define relations between changes to the input and how we expect those input changes to affect the output. So even if you don't know the exact correct answer that you should be predicting, you at least know in which direction you should be going, and then you can tell if your model might be right or wrong. With an example, if I'm trying to, again, predict home prices, and I have a test case that has, let's say, 4 bedrooms and all these other features, and my model predicts that that house is $100,000, if I increase the bedrooms from 4 to 5, the home price should go up. And so even though I don't know exactly how high it should go, I can at least check that it's going up, or hopefully it's not going down. So that's an example of a metamorphic relation. You have your source test cases, so from the training data, or you write your own, and then you'll modify each source test case to generate a follow-up test case according to a particular metamorphic relation. Sometimes you just modify the input and you check, does your model do the right thing? Here with this example of homes and increasing the number of bedrooms, did your price go up or not? Sometimes you will retrain the model on a subset of the input and then measure the model's behavior, and it will hopefully fail a certain way or not, or you'll see some change in performance. For example, if you have a model that's supposed to predict 3 classes and you think it does that well, and then you change the labels on classes, it should, when you're training it, it should start to reduce performance, etc. So I just want to show 2 metamorphic relations today for machine learning classifiers. There are many more in this paper here by Sata and others from 2019. But we'll talk about consistence with directional transformation, and I'll explain what that is, and then adding uninformative attributes or features to the model. Consistence with directional transformation means what we actually just went over with this home example. You change one of the inputs in a test case, it should change the output, and it should change the output in a way that you expect. So in the second bullet here, a non-machine learning example, we don't need machine learning to do this, would be to calculate the average of a list of integers. So let's imagine that my source test case is taking the average of the numbers 1 through 8, which is equal to 4.5. Now let's change one of those numbers from a 6 to a 9. And let's pretend that I can't actually plug that in my calculator and I don't know what the answer is. I know though, if I change the 6 to 9 and I'm calculating an average, that the result I get should be larger than 4.5, which is what I got previously. And so you can take this concept and apply it also to machine learning examples for natural language processing. For example, third bullet down, sentiment analysis on movie reviews. What that means is when someone reviews this movie, did they like it? Are they positive? Are they negative? Happy, unhappy? If your initial test case is saying this movie was fine, I didn't really care, maybe that sentiment is just mildly negative. I didn't really care. Or maybe it's close to neutral, so 0. Okay. If I change the word fine to bad, I don't know what exactly the model is going to return as the score there, but I know it should be more negative. It should be less than the score that I just got. And then a final example with this directional transformation is predicting skin cancer from images. So if I have as my source test case a benign mole, so a healthy skin, and then I sort of cut out, not necessarily a square, I'm just illustrating an idea here, but you put some of like a melanoma skin on top of that image, you would hope that your model then detects that it's melanoma and doesn't just say it's a benign mole. So even though we don't always know the exact answers that we need, especially if they're not classifications, we can at least know in what direction the model should hopefully make the prediction towards if you change the input. Here's another sort of computer vision style example. I don't know if you might have heard of this before, but there's this lore. I actually don't know if it happened or not, but allegedly, however many years ago, back in the day, the beginnings of computer vision and machine learning, someone said, hey, guess what? We're going to build a model that can detect forest versus camouflaged tank. They built the model and it worked pretty well or really well, I don't remember. And it turns out that the model wasn't actually detecting tank versus forest. It was detecting cloudy sky versus clear sky. If this model was actually built, because it's just a lore. So one way that we could try to avoid this situation, or at least flag when it's happening, is to take out the important part of the image. So where I put the black box on these images, just to remove the tank or the forest, train the model with the same labels. And as humans looking at this, we should be unable to tell, was it a tank or a forest? I mean, sort of maybe I need to cover more of the trees and the one on the left, but if I block things out correctly, my performance here should be no better than chance. But if the model with these images with the black squares on them still performs really well, it means it's detecting the background or the sky or something like that, not the object of interest. So that was sort of hinting at consistence with directional transformation. The other thing that I want to share today is how to add uninformative attributes as another type of metamorphic relation. This is basically adding noise. So for a shallow learning example, again, back to predicting home prices, you have the original input, and maybe you add a column of previous sold date, which I'm going to assert shouldn't influence the price at all. And maybe it actually does, and I'm just ignorant about that. That's the little star there, but let's pretend it doesn't. And so you add this feature, you retrain the model, the performance should be the same as before. In deep learning, we're not really typically doing feature engineering as much. So one way I like to look at this is talking about invariance. So applying a transformation or a perturbation to the input that should not change the label of the output. For example, with sentences, if you say that this was a nice movie by John Smith, and you're trying to find out how positive or negative that movie review was, that sounds pretty positive. Maybe it's 0.7. If I change movie to film, these are synonyms. My model shouldn't care. The answer should still be 0.7 or very close to it. So that's one thing that you can do there. And for computer vision, maybe here's a way to sort of hint at adding uninformative attributes. If I have a model that's detecting cars, so like on the right, what if I feed it an image, the one on the left with this red box? It should not detect the red box as a car. If it does, that's bad. And so this is similar to changing the background, although that might actually matter for cars. Maybe they're hoping or relying on the cars being on the road. Changing the color of the car shouldn't matter, all that kind of stuff. And so the last thing that I want to share here is another tool for NLP that allows you to automate the process of generating test cases in some of the ways that we just went through. There's a GitHub here, and let me just load it. And there. So it's called Checklist. You'll see some of the topics that we already covered, where it's just trying to check these directional transformations, minimum functionality, etc. We've covered that. What I want to share is it's a way to help automate the process of writing out these sentences and generating these test cases, which can be really annoying. So for example, here on the screen, they're trying to have sentences about things that would be reviewed: book, movie, show, game. They're sort of implying that maybe these all are synonyms or close to it. You as the user then can define what are positive adjectives and negative, and then you're able to very quickly generate a bunch of different examples here. And so you don't have to sit down and write all these sentences manually. You just build up these sort of data sets once, and then you can recycle them again and again and automatically generate many, many samples. And so if you're interested in this tool, they have a paper on it. They also have code here. And I don't have the time to go anywhere in depth in this, but it just has this nice sort of visual how you can actually run the entire test suite that you've written and check performance for all the sorts of things, or most of the sorts of things that we've talked about so far. And just click here. And so if you're interested, further reading on this topic, there are lots and lots of lists and resources in the domain, or sort of the label of ML ops or data ops. That GitHub link there has, I think, hundreds of different tools and blog posts and articles and all of these useful, very useful things. What I didn't show earlier, because I said it just isn't really meaningful, I'm showing now, or rather just a smaller image of it. There are a couple places that have basically collected all the companies that work to develop tools to help with machine learning. Here's an example one at ML Reef, and I won't make it any larger because it's not really important, but some of the things that I'll mention, there's all kinds of different ways to try to help solve this problem, this higher level problem of ensuring that your machine learning models are actually doing what you want them to do. Or there's ways to label data, tools to assist with that, tools to help you label your data, maybe some automation around that, tools to help you train your model. So if you haven't trained a machine learning model yet, I'll just sort of tell you, if you have, you know what I'm talking about, but you have this model and there are lots of little knobs and features that you can adjust that might impact the performance. How do you keep track of all of that? How do you organize it? As your data comes in, your model intimately is tied to the data that you train it on. If you keep getting new data, how do you organize that and label everything? So there are lots of tools working on that. And I won't go into all the details, or feel free to ask me in the Q&A that's coming up in just a minute or so. What I will say is that if you click on these links or you sort of look online, the area of testing these machine learning models is not something that's been explored in depth because it's very difficult and it's very difficult to automate. I'm hopeful as a practitioner and as a researcher that this is something that we can start working towards in the very near future. It's one of my research interests as well. And I just wanted to mention, I'm faculty at George Washington University. I do teach the machine learning course here for graduate students, Introduction to Machine Learning as well. And so I'd welcome any questions that you guys have right now, and I'll go ahead and stop sharing my screen.
Awesome. Thank you, Dr. Kinga. That was extremely insightful. I don't come from a tech background, so my understanding of the topic is limited. But what you showed about machine learning playing a role in autonomous driving, the cars, it's very interesting for me to see what works in the backdrop, right? We're talking about Tesla entering India very soon, and this would be very interesting emerging area for some of the audience to make a career in. And it's
Definitely.
really at that cutting edge of technology that these people would be working at. So I am going to give the audience a minute to post their questions for you in the Q&A box. So to the audience, if you are looking to ask any questions, you can post those in the Q&A box now. If you don't have questions, I want to check with you how many of you are currently pursuing your engineering and comp science. So I don't have a poll for this, but all of you who are listening to me right now, if you can mention in the chat box, if you're pursuing engineering, what field of engineering are you pursuing? So if it's comp science, mention that. If you're into electrical, mention that. If you're into biomedical, mention that. Okay, so I just want to get a feel of where the audience is coming from. Okay, BSc IT, comp science, and I do have a question come in. Yog, it would be great if you could post that same question in the Q&A box. All right, I see BTech, SC in AI and ML. Hari Krishna is pursuing that. All right, interesting. Kinga, I do have a question come in from the audience. It's in the chat, so I'm just going to pick it up from there. Yug is asking, in prediction models, if he uses MSE and R-squared for the evaluation of the model, so is there a chance that the prediction would not be much precise, and what can he use for evaluating the prediction model? I didn't understand the question myself, but I'm going to post it in the Q&A box as well, if you want to pick it up from there and just read through it.
Oh, great. Yes, I saw that one too, and sorry, just that's okay. I won't waste time trying to figure out the Q&A box, but I believe I understood the question. So the question was talking about mean squared error, for example, as an evaluation of, let's say, something like linear regression, where you're predicting not is this a cat or a dog or blah, but what is the home price? And so in your training data or your test data, you might know that for these inputs, the correct home price should be 100,000. Your model predicts 105,000, and then we take the difference, it's 5,000 off, and that informs us how well the model is doing or not doing. And so I may ask you, Sanjay, to repeat the question, but was the question asking is that good, or how do we do better, or how does that relate to sort of actually trying to build these models? Because you're right, the questioner, I think what they're getting at is how meaningful is that 5% difference? and I don't build models for home pricing. Maybe I should. That's probably a very lucrative sort of thing, especially nowadays. But I think it's sort of, is there a better way to evaluate it? It really depends, I think, on having a subject matter expert, which I am not, but knowing sort of how far off that prediction can be and still be okay. This gets to be quite relevant, I think, if you are trying to compare different models and they're just a couple percentage points off or different in like accuracy or something like that, is it worse, or is it better or worse to have a model that most of the time predicts really close to your target and then occasionally is way off? You do the math there and it has some score, or a model that's a little bit more off the target every single time, but never has this horrible prediction. And I don't know what the answer is. It depends on the business use case, but I would invite, if I'm answering the question, hopefully I'd invite the people designing these types of models to think about something like that, there's not necessarily a hard right or a hard wrong. Some outputs there are in this acceptable range, and maybe you'll have a bit better feel for how well your model might do in the real world if you can define that acceptable range. And so you don't over penalize a model just because its overall accuracy is a little bit worse than this other one that's technically right more often, but once in a while just does really bad. So maybe I answered the question, I hope.
I believe you did. And
Okay.
his question was mainly about how can they do better regression models. And I have information from you that he did get the answer. You did answer his question.
Okay, great.
Dr. Kinga, one check out here. Some of these people may be interested in connecting with you and getting your maybe discussing the emerging trends in the space. Is it okay if they connect with you or LinkedIn, or is there a channel through which they can reach out to you to discuss more on this?
I'll put it in the chat. It was on the slides too, but you can, I'll even say it. I don't know, it'll get lost in the chat, but feel free to email me. My first name is Kinga, Kinga, @gwu.edu. And that's the best way to reach me. And that's my email at work. And I'm very happy to answer questions or follow up with people there as well.
Perfect. I've posted it in the chat box as well, so they'll have it handy. One additional request we are getting from the audience is that you're checking if you're okay with us sharing the recording of the session. Is it all right with you if we share the video recording of the session?
It is, but it would need a password. I don't want to post this publicly because I'm taking images from other papers that I cite, but I would need to, it has to be behind a password or something like that.
Sure, we'll take care of that.
Thank you.
All right. I know you're on a tight timeline and you do have a class scheduled in a bit, so I'm going to let you carry on from here. Thank you again for taking out the time to do this session. It was wonderful and extremely insightful. And I'm sure the audience really enjoyed it. We did have some comments coming in about how the session was extremely insightful. So thank you again for doing this. And you do have a great day.
Thank you, Sanjay. Thank you, everyone. It was my absolute pleasure to be here, and I look forward to connecting with you guys in the future.
Great. Thank you. Take care.
Bye, everyone.
And to the audience, we are not yet done with the session. We are still going to carry on with the session. There are more insights and more information coming your way. So I'm going to invite Ms. Brittany Wright, who's the Director of Admissions, your Graduate Management Enrollment, which is basically the admissions department at George Washington University School of Engineering. So I'm going to invite her to talk to you a little bit more about the programs that GW School of Engineering has, talk to you about the admission criteria, the scholarships on offer as well. And then we are going to take some more questions from the audience for Brittany.
Thank you very much, Sanjay. And again, good evening to everyone in India or wherever you may be logging in from at any part of the world. I am located and based right in Washington, D.C. right now. I am excited to be here with you today to share some more information about the graduate programs that we have specifically at the George Washington University School of Engineering and Applied Science, which you may hear me refer to as C's throughout the presentation, just because it's easier to say that than saying School of Engineering and Applied Science. But I'm here to, again, share some more information with you. I want to start off with a brief overview about the George Washington University. We are a private institution. We were founded in 1821 by an act of Congress. We have are predominantly a grad school institution, which is a little unique, especially in the US. There tend to be more undergrad students studying at US institutions, but at GW, we have about 10,000 students studying at the bachelor's degree level and about 15,000 students studying with us at the graduate level. We have over 2,500 full-time faculty member. Within the university, we have 14 different schools and colleges. So we are a large comprehensive research institution. Along with the School of Engineering, we also have our Elliott School of International Affairs. We have the Columbian College of Arts and Sciences. We have our own School of Business, as well as a law school, a med school. So we really are a large comprehensive research institution. And our main campus is located right in the heart of Washington, D.C. We're about 2 blocks away from the World Bank and the IMF, about 5 blocks away from the White House, 2 blocks away from the State Department. We are located, we take up about a 6x6 block radius in a very safe part of the city. But we also do have a smaller residential campus located in the neighborhood called Georgetown within GW. And then we also have our Virginia Science and Technology campus, which is a facility that is about 40 minutes from downtown Washington, D.C. in Virginia, across the river, closer to Washington Dulles International Airport. So the School of Engineering and Applied Science, we have 6 different academic departments. We have 12 fields of study. We have over 90 faculty members and over 200 million in research funding. So just a couple quick facts and kind of only at GWC's things to consider. We are a very global institution, and we have representatives from over 47 countries in our student body. We are ranked number 67th in US News and World Reports for US institutions. We have a very highly ranked online master's degree program, number 15th, and we are ranked 34th for the QS US University rankings. We are also happy to share that our home base is the Science and Engineering Hall, which is one of the largest instructional facilities in the District of Columbia. It is a Gold LEED certified building. We have some specialized laboratories, such as our Class 100 nanofabrication clean room. We have a high bay with a strong wall and a strong floor for our structural engineering students to do research on, and some high resolution imaging suites. This building opened in 2015. It is the home base for all of our engineering and computer science students, as well as any of our students studying in the hard science fields with our Columbian College of Arts and Sciences. And there's also space for our School of Public Health, and the med school also has some space in the building, which really does help foster that interdisciplinary research and collaboration. So I encourage you to take a look at our website. You can do a immersive virtual tour of the building where you can walk through the building, click on different labs, and learn more information. There are some videos you can watch. And my team also does facilitate live tours, virtual tours of the Science and Engineering Hall. We actually just did one earlier today. So you can also sign up to participate in a live guided virtual tour as well. So I've listed here the Masters of Science programs that we have at the School of Engineering. You can see everything ranges from biomedical engineering, we have civil and environmental engineering, computer science, cybersecurity, electrical engineering, computer engineering. Our regulatory biomedical engineering program is a Masters of Engineering program, which all of the other programs listed here are MS programs. They range anywhere from 10 to 12 courses, so that's 30 to 36 credit hours. It typically takes a full-time student about 2 years, so about 4 semesters to complete their program. And that is if they decide not to take classes during the summer, which some of our students will take classes during year 1 and year 2 in the summertime, but many of our students are using that opportunity to do an internship. We also have a large variety of graduate certificate programs. They're listed here. And what's nice is that a student, while they are enrolled in a master's degree program, can also simultaneously do a graduate certificate program. And the credits that they're doing for the grad certificate program also count towards their MS degree requirements. So our grad certificate programs most of them are 4 courses, so a total of 12 credit hours. Here's a kind of a brief overview of our admissions requirements for the master's degree programs. We do have a completely online application process where our applicants will create a profile in the application portal. Anyone who has attended today's session, we'd be happy to give an application fee waiver. So there's the code right here. You can see SEED OCT21, but please, I'll mark that again at the end. You'll see that code again at the end on the final slide. But we do require students to submit TOEFL, IELTS, or Duolingo scores for English language testing. We have most of our programs have a minimum of an 80 on the TOEFL, IELTS of a 6.0, or Duolingo of a 120. Yeah, sorry, 120. But some of our programs, such as our data analytics program, does have a higher requirement, and that is a 100 on the TOEFL or a 7.0 on the IELTS. We have waived the GRE requirement for MS applicants. This is something that we did last year, and we are continuing to do so, given right now all of the ambiguity. Also, there's questions in terms of with COVID still being present, there are accessibility issues. So for our spring 2022 as well as our fall 2022 admission cycles, we have waived the MS application, the GRE for MS applicants. We do require students to submit 2 letters of recommendation, a statement of purpose, a resume, or your CV, and copies. They can be unofficial copies of your transcripts or your academic records. And for those of you who are doing an undergrad degree right now in India, we do require the 4-year bachelor's degree program, and we do require you to submit mark sheets from each of your semesters. We ask for you to upload those into the application portal for us to review. The deadline to apply, if you're interested in starting your studies with us for the fall 2022 semester or any future fall semesters, our deadline usually stay the same for students who want to be considered for as many funding opportunities as we have. We strongly encourage you to submit and have your application completed by January 15th. We do a spring semester intake as well, but the deadline to apply for a spring semester start is September 1st. And I briefly mentioned scholarship opportunities, but I'm happy to share a little bit more about what we can provide both our MS applicants as well as some doctoral funding opportunities if there's anyone logging in right now who is interested in possibly pursuing a doctoral program. But at the master's degree level, we have merit-based scholarships. They are tuition discounts that range anywhere from 25% to 75% tuition discounts or tuition coverage. And so those are very unique. Not many institutions have master's level scholarships. These are open to all of our applicants. They are not just designated only for students who are US citizens or only for international students. Again, they're merit-based. So we are taking everyone and looking at everyone in our applicant pool. We're taking a look primarily at your grades from your undergrad experience, but also we are looking at all of the different aspects and materials that you have submitted to make sure that you are going to be a good fit for the School of Engineering and Applied Science. We also do offer TA and RA positions, and those typically go to our fully funded doctoral students, though. And they usually include full tuition coverage as well as the stipend for monthly living expenses. What's important to note, though, is there's no separate application needed, though, to be considered for funding. So we will consider all applications and all applicants for any funding that they are eligible for at the time of admission. So when a student receives their admissions decision for their master's degree, they will have listed on their admissions letter if they are receiving an award, and if so, what does that award entail? So just again to point out some kind of advantages of considering, I know some of you are considering studying abroad in the US, hopefully, but something else and a great advantage of being right in Washington, DC. Not only do we have a really strong presence in the city itself, but we are a smaller engineering school located in a much larger institution. We have about 1,000 graduate students within the School of Engineering and Applied Science and about 800 bachelor's degree students. So we really are a small, tight-knit community where our students are interacting with the full-time faculty members on a daily basis. We are doing a lot of research as well with different organizations that are located around and in Washington, DC. And we do have really strong connections to provide our students with unique opportunities for internships through organizations such as the World Bank, the Smithsonian, Amazon, Capital One, Google. You can list them all here, but you can see that we are, like I said, very well ingrained in the Washington, DC environment, and that really provides our students with a really unique opportunity. We also have a designated career services center just for the students in the School of Engineering and Applied Science. We have career coaches who work with all of our engineering and computer science students to make sure you have a proper resume. They'll work on cover letters with you. They have workshops. They teach you how to go about the internship and job search, which is very different in the US compared to what you may be used to in your home country. And there's a lot of opportunities for you to interact with prospective employers. We have career fairs, but we also have employers coming to campus and doing things with us virtually now, but some of them are slowly starting to come back to our campus and interacting with our students. So there really is a lot of opportunities, and there's a ton of resources on their website, but also their office hosts many workshops and meets with many students throughout the semester to make sure that you are fully aware of the process and the resources that you need to utilize in order to find that internship or post-graduation career opportunity. And just to highlight specifically for students that are studying in the US on an F1 student visa, you are eligible to do an internship while you are studying through the CPT program, as well as you are able to stay working full-time in the US still on your student visa through the OPT and the OPT STEM extension process. So that allows students to stay in the US for an initial 12 months, working in the US still on their student visa. The only caveat is that you need to prove that the job that you have, and this is the same for CPT as well, the internship or the job that you have must be related to the degree that you have studied or you are currently studying. And so there's some additional paperwork that you fill out to verify that that is the case. But then for those students who have graduated with a STEM designated program, which all of the MS programs in the School of Engineering are STEM designated, there's the STEM extension to OPT, which allows you to stay in the US for an additional 24 months. So generally speaking, you can stay in the US for about up to 3 years working still on your student visa prior to you needing to apply to be sponsored or for an H-1B visa. And again, just a quick caveat, in 2019, we had about 514 students from Cs who were doing either CPT or OPT. And just to highlight, we had about 37 of them working specifically at Amazon, because Amazon is building its second headquarters in the US right across the river from Washington, DC in Northern Virginia. So about 4 metro stops away from our university, there is a very large Amazon campus currently being built. And so we are excited at the continuing opportunities that will provide for our students for not only internship opportunities, but also for post-graduation career opportunities. And to briefly just highlight some of the additional resources that we provide for our students, along with every student having a faculty advisor, you will also have a professional advisor who is a staff member on my team who works with students to help you with the logistics of being a student. How do you register for classes? You'll actually start to interact with your professional advisor. Once you've been admitted and you have committed to coming to GW, you'll start to have virtual appointments with them, and they're there as a really strong resource for you to refer to at any time throughout your studies with us. We also have an international services office where our F1 students will have an ISO advisor who will make sure that you are staying in status for your immigration purposes. We also have many student organizations. We have the student health services, not only providing students with medical resources, but also for mental health resources. And we have many libraries on our campuses, as well as a writing center that students have access to. So that's just a very brief overview of some of the additional resources that we provide for our graduate students. And finally, I encourage you to actively connect with one of our current graduate students. We have representatives from all of our academic departments that you can actually live chat with through a feature on our website that's listed here. So I encourage you to one of our students who's maybe studying in the department that you're interested in, and feel free to send them asking about their experiences or what it's like living and studying in Washington, D.C. So with that, I will turn it over and be happy to answer any questions anyone might have. Again, please feel free to reach out to us, visit our website. We have lots of information sessions, as well as we will be doing academic department information sessions starting in the beginning of December as we prepare for our January 15th deadline. So we strongly encourage you to visit our website and register for any of those sessions if you're interested in learning more about one of our specific academic departments or programs within those departments. So thank you very much. And like I said, Sanjay, I'd be happy to answer any questions that you may have. Would you like me to also stop sharing my screen?
I think this is all right. We can keep this on.
Okay.
And I'm going to allow the audience to post the questions in the Q&A box. But before we start taking the audience questions, I want to run a quick poll. I want to run one more quick poll. So to the audience, you'll be able to see the poll on your screen right now. This is about your programs of interest, right? So it's not a commitment. There's no, it's just to gauge your interest, which discipline you're most interested in. You can select up to 3 options. So it's a multiple choice. It's not necessary that you have to select all 3. You can just pick one program choice if you're very clear about that. If you have multiple options that you're evaluating, then it could be multiple options as well. But you can choose up to 3 options on the screen right now. So let us know which area of study or which MS program would you be most interested in. Okay. I do have around 60 responses as of now. I'm going to keep this poll open for another 10 seconds. So if you're looking to respond, do so right now. Tell us which discipline are you most interested in. The options are biomed engineering, regulatory biomed engineering, civil and environmental engineering, computer engineering, systems engineering, comp science, and cybersecurity in comp science as well. So those are 2 different programs at GW, but that's an option that you can look at as well. There's data analytics, there's electrical engineering, engineering management, and mechanical and aerospace engineering as well. All right, with that, I am going to end the poll now, and I'm going to display the results as well for the benefit of the audience. So you can see the results on the screen as well. A lot of you are interested in computer engineering and comp science, and then spread across data analytics, electrical engineering, mechanical, and so on and so forth. So, and with that, also apologies about my cat. He's decided to wake up and go all berserk on me right now. Always a bad timing with cats. But great. So I'm going to take the audience question now, Brittany. I do have some questions which have come in. I know you did cover about the study opportunities, but there was a question about study work opportunities for Indian students after graduating from GW. So do you have anything more to add on that, or did we cover everything on during the presentation?
Yeah, I think just to point out, the information that I shared was for all of our students. There aren't certain types of opportunities that are only for students coming from a particular country. But I will say that I know many of our Indian students, they do take advantage of the CPT process, and many of them are doing an internship in the summer between their first and second years. And sometimes it even requires them to relocate possibly to a different part of the US. Or now, though, many of them are also doing virtual or fully remote or partially or hybrid kinds of internships experiences also due to COVID. So if you are interested, though, on the Career Services website, we do have a page for each of our programs, and you can click and actually it will take you, you can actually see the top employers. So where all of our alumni have gone to work. There's kind of a word cloud Tableau feature that you can go and click on for each of the programs. So you can actually see where our alumni have gone to work. And I also wanted to point out that our career services team has a lot of resources for our students to share with prospective employers about what it entails by hiring a international student for an OPT or for a CPT process, because sometimes employers don't realize that they actually can hire an international student who's been on an F1 student visa because of the CPT and OPT process, but they're not aware of that sometimes. And so we have resources and handouts that students can share with prospective employers so they can learn what it is that they need to do, which is actually very little, in order to make sure that they are properly hiring a student who is currently studying on or has recently graduated from an F1 student visa, because that's a very important part of the process, because many of our students are also going to work for smaller startup companies, not just the big ones that we've listed before, which we have many students working at, but again, many of them are working for some smaller companies or startups who might not be as familiar with the intricacies of the CPT and OPT process.
Awesome. And I also wanted to tell the audience one thing. We are hosting another session with George Washington University. This is on the 2nd of November, where we are actually interacting with the Career Services Director at GW. So if you are looking to attend such a session and know more about the career opportunities at GW, you would find the link for that session in the chat box now. I'm just going to post it over there very quickly.
Yes, that's a great opportunity. We'll kind of do a deep dive into the job search in the US. How do you identify jobs? We'll making sure your resume, your cover letter are up to par. What's the process? And we'll talk a little bit more in depth about OPT and CPT and the STEM extension.
Perfect. So the session's topic is how to secure your dream job in the US post a STEM master's. So if you're looking for such opportunities, do register for that session. It would be great to see some of you from today's session joining into that one as well and clarify all your doubts about career opportunities in the US through that session.
Yes, definitely.
Brittany, I do have a question from Ayush, who is an undergrad student as of now, but he's looking to transfer from his engineering program in India and possibly to a bachelor's program at GW. Is that really possible?
Yeah. So it is possible. We do have transfer students. I think it depends. Typically, students will transfer, though, after their first or their second year of their bachelor's degree program. And that is to ensure that you will at least have 2 full years at GW in order to complete the full requirements for your bachelor's degree program. But with that being said, I think it is important. There are separate application processes for transfer students at the undergraduate level, and there's separate deadlines as well. They're typically, those deadlines fall sometimes in the fall semester, but we do have a dedicated undergrad admissions team office, and there's a lot of information on the undergrad admissions webpage specifically about transferring and students that transfer in. So we do allow that, and we do have usually a pretty strong number of transfer students coming in, but it is a process, and there are separate timelines and deadlines for students who are submitting their transfer applications.
All right. And if they have any further queries about it, they can write to engineering@gwu.edu.
Yes.
Would that be correct? Awesome.
Definitely. We'd be happy to answer any other inquiries.
Interesting. Okay, so I think Deep is possibly asking for himself or one of his relatives or family. His question is, what would be your advice for someone looking to eventually make a career in the US, come in for the undergraduate education right now, or finish undergrad in India, and then come to GW for their MS? I know, very personal question, very broad-based, but any suggestions for Indian students who's cost conscious, wants to balance everything out? What is your broad idea on this one?
So yeah, I think it depends on each student. Honestly, we at GW for the School of Engineering, we do not require any work experience. So we have, I would say, about 60% of our students are coming into our master's degree programs directly out of their undergraduate degree programs. And probably about 40% of them are coming with a few years of work experience. So I do think that if you are graduating or you're getting ready to graduate with your undergraduate degree, and you know for sure what area that you want to pursue your master's degree in, and is it going to be really hard for you to get even an entry-level job in that area without a master's degree? If that is the case, then you should strongly consider maybe going and doing your master's degree right away. That's what I did, because many years ago, I thought I wanted to be in study abroad and I wanted to be a study abroad advisor. And so I knew, though, that those jobs were so lucrative, and they wouldn't even look at me if I didn't have a master's degree. So I did my master's right away. And then I was able actually started to work in this office. And that was 12 years ago, and I've kind of made my way from there. But I do think that sometimes students graduate and they're not exactly sure what it is that they want to do. And I think working for a year or two might help you narrow down, or at least help you identify what it is that you don't want to do, which is almost just as important as what you do want to do. So I think that, like I said, I can't say one is better than the other. Again, I think you have to consider your personal situation, what it is that you want to get out of your master's, and what opportunities do you have? Do you have access to some entry-level jobs immediately to help you get some work experience for you to help identify what it is that you want to then really focus on? Because your master's degree is that opportunity for you to really dive in depth in one particular topic area. And so you want to make sure that you know exactly what that is, so you are going to get what you want out of that master's degree, and it's going to help you then with your career aspirations post-graduation.
Awesome. And Brittany, just to follow up on that from Deep himself, are there scholarships available for undergrad education as well at GW?
So there are. I am not as familiar with them, because again, I'm more familiar with our scholarships for graduate level students. I do know that there are scholarships, though. I believe they are still merit-based. But again, all of that information you can definitely find on the undergrad admissions webpage. So please feel free to do an easy Google search for that, or if you are having issues, email us at engineering. We'd be happy to send you the link for that. And I can see the next one. SAT is not necessary. We are test optional. We've been a test optional institution at the undergraduate level for many years, actually pre-COVID. So we do not require undergrad students to submit SAT scores.
Awesome. And even for postgrad now, GRE is optional. There's a waiver available, so it makes it easier and much more convenient for the students looking to apply for a master's at GW. Exactly. On that note, there was also a question about how can one use the application fee waiver. So I understand they need to go to the website, log into the application portal, and once they are into the portal, they'll be able to apply the waiver code. Is that correct?
Yes, when you go to actually submit the application, so after you've uploaded all of the information and documents, it will ask you to pay the fee or select for the fee waiver. There's a text box that you can put the seed OCT 21 in that text box, and then it is a manual process. So someone from my team, once they log in, the next time they're working, they will go in and we will manually waive that for you, and you'll get a notification by email, and then you'll finish the submission process for your application.
All right, so that tells me that they should, if they are looking for the waiver and they're still looking to meet the Jan 15th application deadline, they should ideally do this, get the application ready a few days in advance, because it may take your team also a couple of days to apply the application fee waiver to their profile.
Yes. Yeah, we strongly, you can go in and start your application profile right now. That is possible. You don't have to do it all at once. You can save things and log back in. But yes, once you do go to submit everything, it will take us about 24 hours to waive your fee and for you to then complete the submission process.
Awesome. So to the audience, don't wait till the last minute. Get started on the process soon. If you have everything ready, submit your application ASAP. There's always some advantage in applying early. You get a chance to interact with a lot of, you'll get notifications for a lot of sessions with GWU is doing. You'll be able to interact with the ambassadors, possibly get more clarity on the various program options and or the various career paths available to you. And that is always great to have that information and insight in advance. So if you're looking to apply, go ahead and start the application process soon. Brittany, on that note, I know we are out of time. We had scheduled till 8 p.m. in India, and I know you also have a tight schedule today. So I'm going to wrap up this session. So thank you again for taking out the time and doing this interaction with us. To the audience, as we said, right, there are application fee waivers available. There are also scholarships on offer at GW. So if you're looking for those, do that. If you're looking for more information on the career paths available or how to make a career in the US post STEM Masters, do attend the 2nd November session. The link was in the chat box. We can also post it to you in WhatsApp post this session. So if you are looking to get more insights, do attend that session. And we would look forward to interacting with Brittany again on that particular day as well. So thank you, Brittany. Thank you for taking out the time to attend this session. I am quite confident that the audience really enjoyed it and found the session information. Give our regards to Kinga as well for doing the masterclass, and you have a great day.
Yes, thank you very much. It was my pleasure. We hope to see many of you on November 2nd. And have a good evening, everyone. Thank you.
Thank you. Thank you, audience, as well. You have a great time. Do take care. Bye-bye.